Course 3, if I were to tell you to turn this fraction, this repeating decimal, 0.27 repeating, let's say, and I said turn that into a fraction, you'd probably say, well, it can't be done. You know, I can turn ugly fractions like 2 over 11, and I can turn those into decimals because all it takes is taking the top number and dividing it by the bottom, right? You go like this, and bing, bang, boom. It might not even be repeating. Oh, it is. 1/8 repeating. But to go this way, right? This way, you might say, no way, man. Can't do it. Wrong. There's a trick today you're going to learn. It's not terribly difficult once you get used to it. It has a couple ways you got to, depending on the way that this decimal looks, you got to do it a couple different ways. But it's just a quick 3-step recipe for turning this into a fraction. Check it out. 0.27 repeating. We want a fraction that's worth that, right? Okay, hold on to that for later. So we're going to multiply both sides by 100. Like that. Like that, right? Wouldn't that be true? Because we've effectively moved the decimal over twice, putting it there. But since it's repeating, there's still 27s repeating on to infinity, right? So now we've got this. Hopefully you get how I got that. Now, this is where it gets interesting. We're going to subtract f to get 99f. Now, we're trying to get this repeating part gone because it's really hard to use. Wouldn't it be true that since f is worth, I kind of messed it up. Remember, f was worth this. And if it needs to be equal, technically we can go like this. Now, normally we would say big no-no. You shouldn't have two different things on each side as you subtract. But these are equal based on what we were looking to do. So we are allowed, this is really interesting, we are allowed then to go like that and go like this. Crazy. Now I just got the 27 no repeating part. Wonderful. To get the f by itself, we divide by 99. F is 27 over 99. Don't forget to reduce. We can divide top and bottom not just by 3, but actually by 9 on top and bottom. So we end up with f is worth 3 over 11. Don't believe me? 3 divided by 11, sure enough, is 27 repeating. Let's review what we just did. We took f equals repeating decimal. We wrote that down so we remember it for later. And then we multiplied both sides by 100. It needs to be 100 because we have two numbers repeating. Sorry, I had to deal with a crying baby. I said you multiply by 100 because we've got two digits repeating. So 2 zeros are going to be needed. Now, what happens when we only have one digit repeating? Let's try. The fraction is going to be worth 0.1 and just the 6 is repeating. How you handle that is you multiply both sides by only 10 so that you end up with this. Just 10. 1 0 for one repeating decimal. Got it? Remember what we did then? We subtracted by f, which means we're really subtracting by 6 repeating. Actually, not 6 repeating. Subtracting by 1 6 repeating. Right? That's what this is worth. So now I have 9f is, okay, this is a really useful trick. Instead of showing it just with the repeat end, let's show it with all the 6s, ... so we can really visualize what we're doing here. Okay. If that's the case, then what are we really doing? These really just cancel out because that's true when you're subtracting. And now let's just think about this. 1.6 minus 0.1. That comes out to 1.5. Now we divide by our coefficient of 9 to get f by itself. Pretty ugly looking, isn't it? If we have a decimal and a fraction, we're not really done, are we? To finish, let's multiply it all by 10 over 10, which is fair, that's legal, so that we move this decimal over and we get 15 over 90, which can be reduced by dividing top and bottom by 5. 90 divided by 5 is 18, which can be further reduced by dividing by 3 on the top and bottom. 1 over 6. Okay, now you've got an example of both one digit repeating, and the first one was when there's 2 digits repeating. That should be what you need to do A, B, C, and D.